Hey guys, welcome back. Today we are going to be talking about density. We are going to learn what it is and how do we calculate it. So there are going to be some calculations involved. If you guys remember in your virtual class materials, there is a link to the Desmos calculator. Density calculations are always pretty simple, so you could probably also use the calculator on your phone, or if you have an actual physical calculator at home, you'll be able to use that as well. So let's go ahead and jump right into it. All right, so first, what is density and why is it important? So we're going to be talking about it quite a bit because it is a physical property. Remember, we've been talking in this unit about the differences between chemical and physical properties. Well, density is one of those physical properties. So it's a physical characteristic of matter. So it's defined as the amount of mass per volume area. Okay, so the amount of mass per volume area. Another way of saying this is that density is basically the amount of stuff in a particular space. So how much stuff takes up a particular volume. So density is a physical property, and because it doesn't depend on the amount of a substance, it is intensive. Remember, a couple lessons ago, we learned about the difference between an intensive and an extensive property. Physical property of density is intensive. So what that means is that it doesn't matter how much of the substance you have, that particular substance will always have the same density. So whether you have like 5 grams of sodium or 10 grams of sodium, that sodium will still have the same density. It doesn't matter how much you have, the density of sodium will always be the same. So a higher density just means that there's more stuff in a space, and a lower density means that there's less stuff in a space. So here's some examples. So on the left-hand side, we would have an example of something with a higher density. We can see that these red and green dots are going to represent the matter or the stuff. And then on the right-hand side, we've got a lower density. So these two boxes are the same volume. Okay, so these two squares here are the same volume, but on the left-hand side, we have a lot more stuff, right? We have a lot more matter that's taking up volume in that particular area. And on the left-hand side, we have a lot less. So more stuff per area is going to be a higher density, and less stuff or less matter per volume area is going to be a lower density. So just stop, pause, and ask yourself, which of these jars do you think has a higher density? Jar A or jar B? You can write it in your notes, take a minute to stop and think about it. Okay, so the jar with the highest density is going to be jar A, right? If we were to take these jars and shake them around, we see that jar A is filled up to the top, right? So those jelly beans inside aren't going to be moving a lot, right? All that matter, aka the jelly beans, is taking up pretty much all the entire volume of the space. So if we were to shake that around, we wouldn't see a lot of movement because those jelly beans are tightly packed. However, with jar B, if we were to pick that jar up and shake it around, there's still some volume left there, right? So those jelly beans would be moving around because there's a lower density and there's still volume left in the jar. Now, we're assuming that these jars are the same exact volumes. I know it looks like jar A is a little bit bigger, but just for the purposes of demonstrating density, we're going to assume they're the same volume. So jar A would be the highest density and jar B would be the lowest. All right, so in this course, you could get a question like this, and you will. I'll just go ahead and tell you there'll be some quiz and test questions where you are given a beaker and you have different liquids in here, and they all have different densities. Okay, so again, remember, density is the amount of stuff per volume, and whenever you see a beaker or a graduated cylinder with different substances, the substance that has the highest density will always be on the bottom. Okay, so this might be like syrup or molasses, and then water in the middle, and then oil on the top. If you got a question that said, which of these substances is the least dense, it would be the oil, right? if you got a question that said, which of these is the most dense? It would be the syrup on the bottom. Okay, so most dense will always go to the bottom, and then they will layer out based on their densities. So it would be in order of decreasing densities from the bottom to the top. Okay, so most dense at the bottom, least dense at the top. All right, so again, like I said, most dense will come to the bottom, least dense will go to the top. And here's an example of that again. So if we had this column and I asked you which color is the most dense, it would be this orange on the bottom. Which is the least dense, it would be this purplish guy in the middle. And then you could have like a label on these, like maybe the substances, we would tell you what the substances are, and then ask you to put them in either order from least to most dense. In that case, we would go from the bottom to the top, or most to least dense. You would just have to know we go from the bottom to the top. I think I might have said bottom to top. It's top to bottom for least to most, bottom to top for most to least. Okay? All right, so now that we know what density is, let's talk about calculating density because it's actually pretty easy. So the formula for density is on the left. Density is equal to mass over volume. Okay, so when we're calculating density, step 1, we're going to find the mass of the object. Step 2, we're going to find the volume of the object. And then step 3, we're going to divide. So we can divide our mass over volume to give us density. And then if we're calculating for another variable on the next slide, I'm going to show you how to do that. Right? So density is mass over volume. Now, if we were in the classroom, you could calculate mass by using a scale. So it would tell you how many grams you have. And you can calculate volume by using a graduated cylinder. Now, for us virtually, because we are virtual students, a lot of the times in your problems, you're going to be given the values. So you'll be told how much mass something has, how much volume something has, and then you can calculate from there. Okay? Now, with the density calculation, so density is mass over volume, we're not always going to be solving just for density, right? So you guys know how to do basic algebra where you just solve for a variable. So we could also solve for mass and we could also solve for volume. So here's the cheat sheet of how we can do that with our density formula. And I would recommend making sure you write this down in your notes so that you just have it at a quick glance, okay? So the first one is just the one we've already talked about, which is how to find density. Again, density is mass over volume. So if we were looking for a density, we would take our mass and divide it by our volume. If we needed to find the mass, we would do density times volume. And then if we needed to find the volume, we would do mass divided by density, okay? So again, this is just plug and chug. You'll always be given 2 of those values or be able to calculate at least 2 of those values and then solve for that third variable, okay? So again, I would write this down and have this as a cheat sheet for yourself in your notes. All right, so last thing we're going to do is an example. So we have our given mass of 35 grams, and then we have our volume of 7 milliliters, okay? Now, something to point out, we're solving for density here. So we're solving for density. The unit for density is grams per centimeter cubed. Right? In your Unit 1 quiz, you guys are going to have to do a density calculation, and I write in that last question to be sure to include your units. In physical science, in any science, it is very important that you include your units. We don't want any naked numbers in science class. And what I mean by that is that we don't want any numbers without a unit attached. Okay, so make sure when you are reporting your answers, if you have to physically write it out, you are including the unit, which is grams per centimeter cubed. Okay, so let's just rewrite our density. So let's write our density formula here. So density is mass over volume. And now we're just going to plug it in. Okay, so we're going to have 35 grams. Try to do this as neat as possible with my mouse. And then our volume is 7 mils. Okay. And now we are just going to plug that into a calculator. And let me sorry guys, I was hoping I could pull up a calculator on here and then annotate at the same time, but it makes you exit out of the annotation and then it would erase everything. So I'm going to type it in on my calculator I have, but again, this is just a simple division problem. So it would be 35 divided by 7, and that gives us a value of 5. Okay, so our density is going to be 5 grams per centimeter cubed. And again, that is the unit for density. All right, that is how you calculate for density. In your exit ticket, you're going to do some of the practice problems for calculating for mass and calculating for volume, but on your quiz, the only calculation is just for density. So for density on your quiz, it is going to be mass over volume. You just want to make sure you're including your units because I will take off points if you don't have your units, okay? So that's the gist of it. Density is an intrinsic physical property. Basically just how much stuff is in a given volume. Higher density substances will always be on the bottom if you have like a graduated cylinder or a beaker. Lower densities will always be on the top. And then to calculate, density is equal to mass over volume. The unit of density is grams per centimeter cubed. Okay? If you guys have any questions, let me know. And if not, I will catch you guys in the next lesson.